All right, everyone, thank you so much for coming to this session of the 2021 ASU Data Conference, coordinated by the ASU University Technology Office. My name is Jessica, and I am the Data Analysis Specialist for our Gates grant here at Access ASU. Remember to stay connected and continue the conversation in our Slack channel, #ASU-data-community. And with that, in case you guys didn't already hear, I have already started recording this session. And please welcome our presenters. So today we have Kim Beckert, Nikolas Olm, and Jason Bradshaw. They're going to walk us through some awesome stuff. And I'm going to turn it over to you guys.
All right, welcome everyone. Let me just get this screen up. All right, so thank you, Jessica, for that introduction. My name is Kim Beckert, and I'm with the Academic Strategic Planning team in the Dean's Office of the college. Nick and Jason, why don't you go ahead and introduce yourselves?
I'm Nikolas Olm, or Nick. I'm a Management Research Analyst Senior in the Dean's Office of the College of Liberal Arts and Sciences, and I focus on immersion enrollment planning and data analysis.
My name is Jason Bradshaw, and I'm a Management Research Analyst Senior as well. And my primary focus is on ASU online enrollment management for the college and general data analysis for the college as well.
So welcome everyone. Today we're going to talk about how the College of Liberal Arts and Sciences has started to explore use of user tables. We're going to talk about two specific examples. One having to do with our science and society degree requirement, which will give you some context on that. And then the other having to do with reporting and analysis that we do on student credit hour production, SSCH, which is an important component of our team's role within the college. So first, a little bit about our college. We are one of the 3 liberal arts and sciences colleges at ASU. We are the largest. We're a large college in general. We have over 25,000 undergraduate students. That's both immersion and ASU online. We also are the largest provider of courses that carry general studies credit. So what that means is we serve our own majors, of which we have many, but we also serve majors like engineering and business students. They take their science and their math and their English and their philosophy all within our college. So we offer a lot of courses also in our college. And so Jason and Nick, in addition to having more traditional data analytics roles, also have a heavy focus on helping our academic units in enrollment planning, meaning what courses need to be offered, how many seats need to be offered, when do they need to be offered, what's going on with different populations of students who need those courses, because we serve, again, not only our own students, but everyone else as well. So what this means is we have large data sets often, and we're often working with lots of rows, which is relevant to this conversation in particular. So like probably everyone who did this transition, as we transitioned away from my reports into using some of these new tools, we were looking for a lot of how could we improve our processes? What efficiencies can we gain in using the new tools? And this is particularly relevant because of that enrollment planning aspect. We have a lot of, I'll say non-technical users who were used to kind of bopping around in my reports and now aren't as comfortable with the new tools, nor should they be. That's just not the scope of their role. So anytime we can create ways for them to access data on their own, it's a win for us. And so that, again, user tables plays into that as well. So what are user tables?
Yeah, so a user table is an Aurora user database. That's what we use at ASU, is Aurora database. And it's a cloud relational database service technology. Essentially, it serves as a collection of many databases from different departments across campus. And there's 2 different types of schemas you can use, the team or private schema, or there's the enterprise schema. The team schema is typically used for internal department only, with no plans to share any of that data with anyone outside of your department. And that's currently what we use only right now, is a team schema. But obviously, other departments, enrollment and records, all those admissions, they all have an enterprise schema that they share with everyone outside their department as well.
I also mentioned really quickly that what the user database allows a team to do is to create your own your own specific tables from warehouse data or external data. So it's a way of not just pulling data from the established data warehouse, but creating your own tables for your own use.
All right, so we'll get into our first use case, which has to do with Science and Society Bachelor of Science degree requirement. So some context to understand why we even have to do reporting and process management around this. So every student who is pursuing a Bachelor of Science degree in our college, so not at the university, but specifically within our college, is required to complete a set of courses that are designated as Science and Society. And if you're interested in what that all means, Google Science and Society, the College of Liberal Arts and Sciences, and we have a whole page on it with FAQs that'll help explain a little bit further. But the tricky part about this is, although it acts like a general studies requirement in that it is a course will carry the Science and Society designation, it's not actually an attribute in PeopleSoft. It's not stored anywhere in the data warehouse of what courses carry this, unlike a general studies course where this course is an L and a student takes it and they get the L for literacy, right? And they're done. So we had to build a process around it. And that's because this is a college level requirement, not a university requirement. And so it's not a searchable field in class search either. So how will students know when their advisor tells them they have to take a course to meet the Science and Society requirement? How will they find the courses? And so that's part of why we have this kind of external process that we've always had in the college. So the way Science and Society works is a course goes up for approval. It's submitted by an academic unit to get Science and Society designation through our college curriculum committee. It gets approved. And then it gets added to our master list. Again, this is nowhere in PeopleSoft. This is an external file, essentially, that we have to keep track of. And we have effective dates because courses can come in and out of Science and Society status. And if you didn't take the course when it was actually designated Science and Society, then you don't get the credit. Then, as I mentioned, students need to be able to essentially query against that and know what courses are being offered in this semester, because the list is very long of all of the eligible courses. And of course, they're not always offered every single semester. So we need to make that available to students since they can't look for it in class search themselves. And then once the student takes the course, it actually has to be applied, and that happens through DARS encoding. So our DARS encoder, they have to be up to date as well on what courses are eligible for Science and Society credit. So the point here is it's an external process. We can't hook into university processes on this. Multiple hands touch this process from the curriculum committee all the way through to our DARS encoder. And most importantly to this, non-technical staff need to make updates, meaning it's not someone who's going to go in and make a change to an Alteryx workflow or be able to go in and actually write a query to pull something down for a student. We need our staff to be able to grab the list that they need, post it on our website, answer any questions, and make sure that we have a clear connection between an approved course and then actually a student getting the credit.
Okay, thanks, Kim. So I'll take you into a demonstration of how we utilize Google Sheets and Alteryx to get the files that we need. So I'll go ahead and share my screen. Are you guys seeing my Google Sheets?
Yes.
Yes, okay. It's not showing me, okay. So this is what our Google Sheets file looks like. So it's a list of courses. Over the years that Science and Society has been a thing. And then what the course description and approved special topics title, if it's a special topics course, where it was at the time this Science and Society course was approved. So with this Google Sheet, like Kim mentioned, our non-technical users can come in here and update this Google Sheet. And then from this Google Sheet, I actually have the Google Sheets input tool that connects directly to this Google Sheet. So it's essentially a live connection. Anything that's updated in the Google Sheets is updated here, and then I query off that live data. And I do want to mention that there's some great information on the analytics site in the trainings folder about utilizing the Google Input tool, and it'll show you how to connect to your Google Sheets in that training. It's very helpful. So here we have the Google Sheets input tool, and then we're querying the courses in our Google Sheets input against what the courses currently are listed as in the database. So we're pulling in what the course desker that was approved for the Science and Society courses, and then what their current description of that course is. And if those don't match, we kind of want to eliminate those. The same with the special topics title. If the special topics title isn't the same, we want to not show those as current Science and Society courses. And so this is the workflow we utilize and do some more, just transformation of the data and filtering out certain pieces, and then a few formulas in here, and then getting unique values. And then here at the end in this container is where we actually write the data to our user table. So all this information in the Google Sheet eventually gets written to a user table here. And there's good information on the training site as well about how to write to a user table and create a user table in there. And then so from here, when we write this data into the user table, we can also connect to it wherever we need to. We can connect to it through Tableau, we can connect to it through SSRS. The report we use for this is actually a SSRS report, which I'll show you in a second. But I also want to mention we do also utilize the Google Sheets output tool that actually writes to this same file, but in a separate sheet. And so our non-technical user can actually see what's outputted from all of this, transformation that's going on. They can see what it looks like after we take the data and do the transformation, and then kind of do their own validation through Google Sheets to make sure we're getting all the data we need, and see if there's any errors between what we started with and what we output. And so I'm going to open the report builder file. So here's what the back end of the report looks like. It lists each course separated by session. And you can see in here, all you have to do in your data set, very simple SQL query, select all from the table, the user table that we created. So the Science and Society is the user table that we created. And it'll take all the data that's from that Alteryx workflow. And then we run our report. Select our values, and this should run pretty quick. And we get our list of courses that are currently scheduled for the semester you're choosing. So this will be what the students see when we download this into a PDF and upload it to our Science and Society site. So this is how we utilize the user table to create a more efficient report. Previously, we had to actually use Hyperion Studio, and we had a stale Excel file that every time the Excel file got updated, we had to re-upload the Excel file into Hyperion, rerun the query, and then I had to send that query out, or send the PDF version of that report out to our curriculum coordinator, and then she would upload the file, where now she can upload the Google Sheet, our curriculum coordinator can upload the Google Sheet, do any changes she needs to. She can run this report on our analytics site, and then she can actually download the PDF all by herself, so we don't have to touch it at all. So this user table has been very beneficial in making great efficiencies in this process.
And Nick, just to confirm, there was a question in the chat about the training website. That's the analytics.asu.edu.
Correct.
And the support box. Yep.
Correct.
Thank you.
Yeah. Mm-hmm.
Okay. Now we're going to switch gears a little bit and talk about another application of our user tables. Can everyone see my screen? So now we're going to switch gears and talk about SCH and SCH reporting. So SCH stands for student credit hours, but for those of you who aren't familiar with it, what exactly is it? So course SCH is a metric, or SCH is a metric that measures that really is just the number of enrollments in a course multiplied by the number of credit hours. So for example, let's say you have 30 students enrolled in a 3-credit course. That is equivalent to 90 SCH. And while the focus here will be primarily on the funding logic, there's also just the basic course logic where you can just write your own logic in a regular, just from the PS Student Enroll and one of the class tables. But while the focus here is on funding, it can also be used as a general metric of course enrollment effort. And that's often used to compare courses, trend analysis, and in this case, funding calculations. We're also going to focus on 21st day census data, but again, there are some live tables that actually have the funding logic built into them, but we won't get into that. If you have any questions, you can feel free to reach out to us. But we're going to focus on the census data here. Okay, hold on one second here. Okay, so there are two primary census tables that hold the what's called the instructor funding data. They're both located in They're both in both Redshift and user databases. On Redshift, it's on the ASU student schema. So, and then on the user database, this is the Census Enterprise Student Schema. These tables are managed by Institutional Analysis. They're the primary subject matter experts in this area. So if you have any questions regarding the tables or access to that schema on user database, we sometimes use the user database because sometimes data might be available a little quicker than in Redshift. And again, these are both census tables. So there's two tables. There's the SSCH by instructor funding. Note the 2 underscores after CS. That designates it as a census table and not just like a 21st day snapshot table. So keep that in mind, that those double underscores are, for those of you not familiar with census tables, those are actual designations, that those are the official census data, the official census tables. The SCH by instructor funding, the first table is usually measured as of the it's always measured as of the 21st day of the term, or as we say, 21st day of AC/C. The CSSCH by instructor funding B table, the B at the end means that that's data, it's captured as of the 21st day of session B. So there's two separate tables. And this is important primarily for online funding, because we actually, for online funding, we look, or actually just regular SCH, just course offer funding, you look at, for online, it's both AC and B. But for immersion, you only really need to focus on the funding table, because we only measure that as of the 21st day, or AC, which means that even if a student's enrolled in only B session courses and they're immersion student, then that the SCH, what they're enrolled in as of the 21st day counts. I think that makes sense, but if you need any clarification, let me know. So we're going to quickly talk about the funding rules and the key factors that we decided to use this to load this data, to use this as a user database. So you pull the data from the 21st day tables, from the census tables above. However, there are several funding rules that can be somewhat complicated that you need to apply to the data once you pull it. And for each semester, it generates around 100,000 rows of data. Actually, that's only for online. When you add in the immersion, it's closer to 200,000 rows of data per semester. And usually when we're reporting SCH, we're reporting 5 to 6 years worth, going back 5 or 6 years for both fall and spring. So you can imagine this multiplies, and you can pull make the original raw data set pretty large. And again, we need to apply somewhat complicated funding rules post query, and that's usually a 2 to 3 step process. And I'll illustrate that with a screenshot of our Alteryx workflow that we built to do this. Once you apply these funding rules, that will usually reduce your raw data set from around 1.5 million rows to about 500,000. And another reason why, since it's a census data, we only need to run it twice a semester, usually once after session AC, once after the 21st day data is available, and once after the 21st day session B data is available. While you could build a report from the raw data, build reports and extracts from the raw data set, it would be difficult to do that, to have the reports run in a timely manner. So AUDB allows us to write and update the final data set, including all of the logic, and build reports from that reduced data table. So here's an example of the workflow we use. Now you'll see some of these notes in yellow on the left, especially the ones that say online headcount and online SCH for AC and dynamic. Actually, that's for everything, not just online. But when we initially built this to test it out, we tested it on online, because again, it's the most complicated one. So you can see that the three input tools down on the bottom container are just dynamic input tools, and then the left input tool on the leftmost green input tool is just allows us to modify the terms really quickly. So what we do, this is just SQL. It's very simple SQL. Actually, we sort of divided the query up into two sections. Again, we pull A, C, and B separately because of the two different tables, but we do union and join those because we don't report our online SCH at the session level. We just sum it all together for the AC courses and the BC courses. So, and since we're primarily reporting this, usually our data grain is usually at the by term, and then by division and by unit, sometimes by course, and then sometimes at what we call the funding level, which is usually undergraduate funding, and then graduate level non-doctoral funding. And that gets in that whole, what I just talked about was how the funding logic works for SCH. So, so once we get all of the data, once we get all the raw data, then this is where the fun stuff starts. We apply the post query logic. And you could actually write this logic within your query, but then you're already reducing your data set. But sometimes you want to have the larger data set to check and validate your data to make sure that what you're pulling back is correct. And so doing that after you pull the raw data allows you to do some comparisons, some checking. Sometimes, and we did have a logic change that made a major, that shifted some of the way we report this data is now changed starting in the fall 20. So we had to go back and make some changes and make some comparisons. So these two primary tools here, the one on the left applies some of the dynamically, for online courses, we have to also apply a dynamic sort of binning method for online dynamically dated courses that requires to determine where this dynamic course sits. Does it sit in A, C, or B? Because that's important because because of the enrollment, depending upon where that enrollment snapshot occurs on the 21st day or 21st day of B, can affect the SCH and the funding. And also with the post query logic, like I said before, this second formula tool right past this directly to the right of the sort of the check or select box, that contains about 8 or 9 different logic pieces that we have to apply and then check. And then so we do all of our checking, we do all of our validation, then we just write to our user database. And then from that table, that reduced table set, once all of our checking and validation is done, we can write our reports, our extracts very easily and very quickly. And then if we tried to write this as an SSRS report or in Tableau, where we're just running the raw query and then doing all the logic there, it would probably take 5 to 10 minutes for the report to load. Now by itself, this query only takes about 2 to 3 minutes to run. I have noticed, but it could just be maybe the way the SQL is written. So it could be more of a thing we can explore later on to optimize the SQL. It does tend to run a little bit faster on Redshift than user databases. But we generally will use the user database connection because the data is usually available sooner. Anyone have any questions about anything here? So we're going to talk about, I guess we should have changed the pros and cons, opportunities and challenges, because that's sort of what we decided on. So for the opportunities, as Nick demonstrated with the Google Input tool, a non-technical user can update a user table. We can allow them to update the user table without actually having access to do the actual behind-the-scenes database work. So again, with the Science and Society example, since we have a lot of non-technical users that sort of touch that data and help us manage that data, it's important for them. They can actually assist us with updating that data through the Google Sheet that Nick demonstrated using the Google Input tool. And then again, like Nick also talked about, the Google Output tool, which will output that updated data into a separate tab on the using the Google Output tool. It also allows us to check the modified data through the workflow versus what was initially entered. User databases for large data sets where a lot of data reduction happens, as in the SCH example, can result in more efficient report and extract runtime and rendering time. You can also do a lot of your pre-processing with the Alteryx workflow before you write to the user table. It allows you to do a lot of pre-processing for complicated logic, which applies to both the science and society and the SCH that we just referred to. And again, for the SCH, it's easy to append additional data fields to user tables and reports without having to rerun the entire data set each time.
Okay, thanks, Jason. So some of the challenges with these user tables, it does require a lot of pre-planning, knowing what fields you want to take from what other databases or what other tables in the data warehouse. If you want to utilize a Google Sheet to incorporate that data into your user table, what calculated fields you want to put into this user table, how often you want to update this user table. So it does require a little bit of pre-planning in order to make this user table the most beneficial it can be. Another challenge is, so it's shared Power Queries. So you can connect to a user table using a Power Query, but everyone who utilizes that connection to that user table has to do it in the BI desktop workspace, as well as you have to have access to that schema that we created, or that table that we've created. So an instance for us is our enrollment report that we send out weekly. If we were to build that in a user table, we actually send an Excel file out, and the data on their end wouldn't be able to be updated because most of our end users do not have a BI desktop workspace, or nor do they have access to our own team schema or user table that we've built. So shared Power Queries do not work in that aspect if you are sharing like an Excel file that has a Power Query in it. And then team app ID versus individual owner. So when you create your user table, you essentially, I think it defaults to the individual owner's app ID in Alteryx. And then on the back end or after the fact, you have to actually change the owner's role of that user table to a team app ID. If you don't do that, the individual owner, if they leave, no one else can access that user table, and everything in that user table is gone forever. And I believe no one even on the BI team or an UTO can access that user table. So it's crucial that those, if it's an individual owner of that user table, it's changed to a team app ID. So everyone who's associated with that team app ID that's created can access that user table. So that's definitely a challenge, because if you don't do that, you can lose some data. Those are the opportunities and challenges.
I want to add to, so yeah, thanks, Nick. And want to add that we just demonstrated 2 different examples, but we have several other use cases. So if you're interested in exploring what else we might be doing as a guide, or if you want any input, we'd be more than happy to share some of the other applications we're using these for. It's primarily, I think it's primarily when we figure out that a report or a Tableau extract or something is running really slowly, and maybe we can utilize a user database table to make that run faster. I think that's the emphasis. Is like, how can we make a report not take 5 minutes to load versus maybe 30 seconds to a minute? Because when you have a report, we found that you start losing users quite quickly when they go to a report, and the report takes forever to run, and then it's not loading in a timely manner. And again, there's also, and to the last point that Nick made on the team app ID versus individual owner, of course, if you have an app ID, you can actually use that in your Alteryx workflow to automatically write to that table. There's actually on the UTO Analytics site, there is if you have your own database schema, then you can, and you want to help administer your user database table, your user database schema that you have for yourself, it also lists what you have access to. Then that's an excellent tool, and there's some instructions at the bottom of that table to help you change ownership of tables and how you would do that in an efficient manner.
Thanks, Jason. So with that, we're going to move on to just any questions or discussion that anyone has on this or in general for us. All right. Well, with that, then we will bid you adieu. Thank you very much for coming. Jessica, do you have other things to close with?
Thank you guys for sharing your awesome expertise, because my very limited Ultrix brain went kind of crazy with your workflows. But one day I'll get there. So thank you guys so much.